Thank you for taking the time to watch this walkthrough video. My Year 9 class recently completed a higher paper online, and I know you find it quite difficult. And so today I'm going to talk through how we would tackle many of those questions. I won't do every single question. The thing about a higher paper is you will find that there are some topics that maybe you've never been taught, but we're testing, can you reason mathematically? Can you apply what you know to solve problems, even if you haven't seen them before? So sit back, enjoy, and I hope it makes a lot more sense. So here we have the instructions from the online exam, and I want to just stress how important it is to read those instructions. So you know how much time you have, and you know you are allowed to use a calculator. So if there's no calculator, do show me all of your calculations. If calculator is allowed, then please use it. There's a lot of questions to get through, so please do make good use of that calculator. And my recommendation with questions like this is to start very quickly, spend 5 minutes, run through the paper. Which questions am I confident I can do, and do those first. And you may find some questions halfway through or even at the end you are able to do. Don't just start at question 1 and then do 2, 3, 4, get stuck at 4 and you haven't got time for the rest of the exam. So question 1 looks like an awfully complicated question. It's got all of these words there trying to make sense of. We just do it step by step. And we're going to start by working out how do we convert from standard form to ordinary number. Let's do a quick recap. So here you'll see that I have written out on my right hand side 5.6, and I've put that in units, tens, hundreds, thousands, tens of thousands, etc. So if I was want to multiply 5.6 times 10 to the 1, that means multiplying by 10. So we're going to move along each of these through one place. That would become 56.0. If I was wanting to multiply 5.6 by, let's say, 10 to the power 3, we would go through 3 places. So 1, 2, 3. So my 5 would move to there, my 6 would move to here, and then the rest would be zeros. So it's the same concept here. When I want to write 5.6 times 10 to the 7, it's going to move through 7 places. And if we do that, so there I've written out our answer, and you can see that it is 56 million. Now if I wanted to check that, I could do this, go 1, 2, 3, 4, 5, 6, 7, and confirm that it is 5.6 times 10 to the power 7. Then I'm asked to work out, we're asked to add the populations of Wales, Scotland, and Northern Ireland. Well, I could do this by hand, but actually the easiest thing is just to put that into my calculator. Why spend time doing the calculation by hand when it is a calculator question? So if I do that, then it works out on my calculator as 104,600,000. So I want to put that into standard form. So I'm going to go 1.046 and then times 10 to the what? Let's have a look. 1, 2, 3, 4, 5, 6, 7. That'll be times 10 to the power 7. And then finally, total population predicted to reach 72.9 million by 2041. Calculate the predicted percentage increase in population. Well, how do we do that? First of all, I need to know the total population of the UK. So if I worked out there, the total population is 6646 and then 4 zeros. I know that got 72.9 million in 2041. First thing I want to do is work out the increase and again put it into my calculator. So that works out at 644 and 4 zeros. And then my percentage increase, I divide that increase by the starting point. So much of a proportion of what I started with is my increase. So I'll put it into my calculator. And then that gives me as a decimal 0.096. What I wanted is a percentage. So I multiply it by 100 because we know that 1 is 100% or 0.5 is 50%. So that's going to be 9.69% in terms of an increase. But I'm asked to give it to two significant figures. So I'm going to write that as 9.7%. And now we're going to put all of that into MathsWatch. So there I've put them into MathsWatch, and you'll see here that trying to write times 10 to the power 7, we use that little symbol, just like a hat symbol to indicate it's 10 to the power 7 to make that superscript, because when we do the plus, it allows us to do squared or cubed on this version. And then over here I've written out my working out because there are some working out marks here. So even if you didn't get every single one right, you can still get lots of your working out from this and hit submit answer. And notice we have got 7 marks. From one question it's 7 marks. But the wonderful thing is that the pass mark for this paper is 16 marks. So you are almost halfway there by doing the first question. Yes, it was a hard question, but you're almost there. Compare it with the foundation paper where you would have to get perhaps 45 or 50 marks just to pass the paper. And that's the challenge that we have. So we continue on to question 2. We're looking at map scales. And we're going to do a little bit of loci work. So let's look at that a little bit closer up. And you can see here I have written down 1 centimeter is 50 meters, and we want to work out what is 180. So how do I do this? What's my scale? Well, one way of doing it is to work out what do I got to multiply this by to get there. So in my calculator, I do 180 divided by 50. So I'm saying that that is 3.6 times bigger. So it's going to be exactly the same on this side to maintain the ratio, and so that would be 3.6 centimeters. So that's one way of doing it. Obviously, all the ways to do it, you could say 2 centimeters is 100 meters, 4 centimeters is 200 meters, but that's probably a simpler way to do it. Okay, we're told that 1 centimeter represents 50 meters is written in that form. So what I want to do to compare them, I want to convert. I want to say 1 centimeter to 50 meters. Well, how am I going to write that? How many centimeters are there in 1 meter? Well, I know that 1 meter is 100. So to convert that into centimeters, I'm going to say that is 50 times 100. So add another 2 zeros. And that is therefore equivalent. So then I can write it in the form of 1 to 5,000 because now my units are the same units. And then I'm going to do something a little bit similar with this play park in just a moment, because I work out that my play area must be no more than 50 meters from A. So that's going to be 1 centimeter. Must be closer to CD than BC and within 60 meters of B. So doing the same conversion there, within 60 meters, if I go over here and say, well, let's say 1 centimeter is 50 meters. I want to turn it into 60 meters. What I want to multiply by or divide by, as the case may be. So let's say 60 divided by 50 is going to be 1.2 times more. And so from that, I can, I can see that if that's 1.2 times more, that will be 1.2 centimeters on my map. Let's go back to MathsWatch and put some of those in. So this is now a construction question. I've worked out it has to be no more than 50 meters from A, which is 1 centimeter. So I need to get my compasses. So there's my compass. I want to draw a 1 centimeter radius. I'm just going to move this down until I get to 1 centimeter. And nearly there. And there we are. So now I'm going to move this to A. So I'll put that just on A. And then if it's no more than 50 meters from A, that's going to draw an arc. That there is exactly 50 meters from A. So it's going to be somewhere in here, inside that, or possibly on the outside. Similarly for B, I am told that with B, within 60 meters. So we worked out that was going to be 1.2. So let's just increase that to 1.2. And I'm going to draw an arc there. And here's my arc. So if it is going to be within 60 meters of B, it's got to be inside this arc. So that tells me it's going to be somewhere probably in here where both of those are represented. And then so that you should have been able to do with your existing knowledge of constructions. The last one is closer to CD than DC. BC is something we won't certainly haven't taught you. Probably wouldn't teach that until possibly year 10. And to do what's closer to one line than the other. Well, there's CD and there's BC. So my line is going to be something like this. It's going to be a line like that. And what I do is a little bit complicated, but I'm just going to show you how we do this one. So I start by putting a mark on C, and then I'm going to just draw an arc here, and then I'm going to draw an arc there. I'm actually going to construct what's called a bisecting an angle. And we're going to construct a rhombus. So I'm going to just draw this, and we're going to make an arc just somewhere there. And I'm going to go back up to here. And I'm going to see where that intersects. And I can see that it intersects just there. So what I now do, and this does seem a little bit odd, is I'm going to draw a line from there all the way through there. So there's several ways of doing it. I'm going to use these 2 points here. So I'm going to draw one line at C, just drop it there. And I'm going to draw another line just through where they cross. So I can see that they cross just there. I can see that here they cross. So somewhere along this new line I've created is closer to CD than BC. Well, that would be exactly the same between C and D. So it has to be to the bottom of that. So then finally, I'm going to use this tool to mark where it should be. So I've dragged a little X here, and I'm going to move my X to somewhere around about here. In this place here, I can see it's less than this arc here. It's less than this arc here, and it's closer to DC than it is to BC. So somewhere around about there is where I can place that construction. Now that is a particularly complicated construction, and MathsWatch often is not very forgiving, and it may well be that it doesn't like that, says I'm slightly out. We'll have a look and we'll see how that looks. And there you go, actually gave me the marks. I was close enough. And notice I'm up to 14 points and I'm already at a grade 3. Let's try question 3. So this here is a scatter graph, and I'm asked to indicate a relationship between the amount of rainfall. First thing I'm going to do is I'm going to draw myself a line of best fit. So I'm just going to use this thing here and just try to work out approximately where is my line of best fit. Something like that, I think, probably is about par for the course, maybe a bit more like that. Yeah, we'll go for that as a line of best fit. It's a little bit of variation there. And I can see I have largely a correlation there. It's kind of the more rainfall, then the greater the number of visitors, because it's an indoor attraction. So I can say that that is a positive correlation. You might not have come across that term, but it's good to learn this term. And one of these points is an outlier. Well, which one is it? Well, which one is furthest away from the line? It's clearly this point here. So what's the coordinates of that point? That's going to be about 5.4 maybe. Try that, 5.4 approximately. And 110 perhaps. So we're checking, can the student read those scales? And then I'm asked to, so I'll just get rid of those points. I'm asked to use this to work out the number of visitors on a day with a rainfall of 3 millimeters. So what I might do is, again, drop a line. I'm going to look at 3 millimeters just there. And I'm going to go up and see where does that cross my line. So I can see it crosses my line at 200. So I'm going to say I'm estimating it's 200. Now, if your graph is a little bit different, you might find that you have maybe 190 or 210. There's a bit of variation allowed. And then we're asked, what's the amount of rainfall on a day with 300 visitors? Well, again, I'm going to drop a line there. Let's put one up to 300. And let's just move this and see where are we at. And that looks to me that that's about 4.3, 4.4, maybe 4.5. It's kind of hard to see there. I'll go for 4.5 and see what it says. And then we're asked why the rainfall graph cannot be used to estimate the number of visitors with 9 millimeters. So what's our problem there? Well, let's have a look at this. The biggest we have there is 5 millimeters. So what's going to happen over here? Well, we don't know. Is it going to go up straight? Well, we don't know because it's what we call extrapolation. It's outside the range of data. I'm going to write that and we'll see if MathsWatch is happy with that. It's outside the range of data and therefore it's going to be unreliable. We might want to use the word extrapolation. Let's see how we do with this question here. And submit answers. And look, we are 3 questions done. We have passed our paper. We are at a grade 4. Really, really good. Now, the thing is that the reason we're doing the higher is we don't want you just to settle for grade 4. We don't even want you to settle for grade 5, to be honest. We want you to keep working on. Question 4 is a ratio question. It's combining ratio and fractions. There's several ways of doing this. We could do it with a bar model, and that's the good method. I'm going to show you how to do it just using fractions by themselves. And so here, 4/5 of the students study a language. So what can I say? So 4/5 of the students study the language. And of those 4/5, 1/3 do German. So I can work out what's 1/3 of those 4/5. Well, I can use my knowledge of multiplying fractions to say that's 4 over 15. So 4/15 of all students study German. So I can say that. So out of 15 students, 4 study German. Of 15 students, how many don't study German? Well, it's going to be 15 take away 4. So of 15 students, 4 do German and 11 don't because there's 15 in total. So that at one level is a quick way of working out how to do it. We could also do it with bar models, But let's put that into MathsWatch and see if it likes it. But notice that I have to write it carefully, saying the ratio is. And there I have typed that out. There's my 4/15. There's my words. Because I've got 3 points here for this question. And we are halfway through grade 4. Moving on to question 5, we've got some gradient work. Now I'm very aware that this is a question that we have not looked at, and with all of the lockdown issues, it's been quite a challenging time for us all. But I'm going to talk through how we would do this. You see I've just drawn a line there from A to B. And to find the gradient, well, I know that we define the gradient. The gradient is between 2 points, it's the y difference divided by the x difference. So am I going up a lot? Am I going down a lot? That's my definition of gradient, and I use that expression m. So how do I do that? Well, I know that here, this is at a y value of 5, that's a y value of 2. So I can say that that is 5 take away 2. And the x difference, that's -3, and that's 6. So I can do divided by -6 take away, I beg your pardon, on the wrong, am I? That should be -3 take away 6. And I'm going to work that out. Now I can use my calculator for that. It's not a problem to do that. And if I put that into my calculator, that gives me, that's 3 divided by -9, and that is -1/3. So my gradient is going down. It's not going down very steeply. It's a shallow gradient, and there we go. So then I'm asked to work out the equation of line ABX. Now, this is new. There's several ways of doing it. One way of doing it is basically simply to say that I know the gradient is going to be -1/3. And I know that the equation of a straight line is y equals mx plus c. Now, I haven't taught this to you. I'm just showing it to you for the sake of it. So in this case, it's going to be -1/3 x, because that's what we have as my gradient, plus c. And that's my equation. Now I want to work out what is c, because x and y will vary depending on where we are on the line. So one way of doing this is to say, well, right now I know that at point B, when x is 6, y is 2. So I can substitute in that 2 is -1/3 times x, which is 6, plus c. And if I do that, I get 2 equals, so -1/3 times 6, well, 1/3 of 6 is 2, so that's -2 plus c. And then I can solve this equation by adding 2 to both sides. And that becomes 4 equals c. And that tells me that my equation, let me just change my color here, just make it a bit clearer. My equation will be y equals -1/3 x plus 4. And that's what I will have as my equation. Now, there are other ways of doing this. I'm not going to worry about explaining other ways. If you look up, say, the MathsWatch clips, then you can learn some more about that. And hopefully we'll get to look at that later on this year. So what about point C? I'm told it's an equation parallel to AB. Well, that means the gradient is the same. So I can do exactly the same thing. Y equals -1/3 x plus c. It's going to be a different c because it's going to be parallel to. But the equation, the gradient will be exactly the same. But this one goes through 0, -5. So this time I can just substitute in 0 and -5. So when x is 0, y is -5. -5 equals -1/3 of 0 plus C. Well, we know that anything times 0 is just 0, so that tells me that that will be C. So my answer would be y equals minus 1/3 x take away 5. Now, I appreciate that this is new stuff, but nevertheless, it's good to see how would we do these questions. Let's put that into MathsWatch. And there I've done that and hit submit answer. And then we'd actually be up to a grade 5. Now, I appreciate you probably wouldn't have hit grade 5 yet because we haven't done that work recently, but nevertheless, if you've taken the time, it's good to look at that. Okay, let's have a look then at our game with spinners. We're told we have these. We're told that we add them. So it's a very quick point just for adding these. So 2 and 3 is 5. 2 and 5 is 7. 2 and 7 is 9. 4 and 2 is 6. 3 and 4 is 7. 5 and 4 is 9. 2 and 6 is 8. 3 and 6 is 9. 5 and 6 is 11. And 7 and 6 is 13. So what's the probability of getting an odd score? Well, how many ways do I have of doing it? I have 12 different possible answers. How many of those are odd? Well, there's a 5, a 7, a 7, a 9, a 9, a 9, 11, 11, and a 13. How many of those are odd? 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that that is 9 ways out of 12 to do that. Now I could simplify that. And we might want to write that as a decimal or write that as 3/4. And we'll see if MathsWatch is happy with that later on. So part C, we're going to apply this. We've got this thing about a game to raise money for charity. We're told that 60 people play the game. I want to work out how much money is raised. Money raised is going to be 60 people, and they each pay 30 pence. So what's that going to be? How much is that? Well, let's put it in my calculator. I'll put it into pounds. So 60 times 0.3, and that tells me we raise 18 pounds. But how much do they have to pay? How many of those people are likely to win? So number likely to win, likely to roll or to get 7. Well, what's our proportion? There are 2 ways out of getting 7. So that's going to be 2 out of 12 times 60 people. So what is that going to be? So 2 out of 12 we know is 1/6 of 60 people. 1/6 of 60 people is 10 people. So my calculations there. And if 10 people win, they win a packet of crisps. Now, so we got 10 lots of crisps at 20p. Well, I can work out that that's going to be £2. So what's the money raised? Well, it's £18. Take away, so raised for charity should be therefore that £18 take away the £2 in prize money, and therefore that should be, if we're right, £16. Let's have a look at that and see if MathsWatch is happy with those. And it looks happy with that, yeah. And then we can move on to question 7. Now you'll notice it says here time remaining is 46 minutes. I'm halfway through. That's partly because I'm going really slowly to show you how we do this. But let's move on to question 7. Now this one I'm going to skip because we haven't done very much work on graphs. I will show you the answers, but I'm not going to take time to talk about it. So those there are the answers. I'm not going to include that in our score, but just so if you want to have a look at those. So we have here next question is one looking at volume and looking at pyramids. Now, actually, interestingly, we were going to be looking, in terms of plan, we were going to be looking at the volume of these 3D shapes. Some of them you've seen before, but probably the pyramids you haven't seen after half term. So we were almost ready to be able to do that. But the other thing you need to know here is how we make sense of mass, density, and volume. So let me just show you this. So we have, first of all, a formula triangle. So we have mass, density, and volume is there. I have a diagram here. The one bit I need to add is the fact that if this is 8, then that must be a height of 7. And I have a couple of formulae I can say. The formula of a cuboid is going to be the should we say the length times the width times the height of the cuboid. And the volume of a pyramid, and this is a new one, is going to be, again, it's the width times the length of the base times the height, which is similar, but we divide it by 3. And this is one of the formulae that you are going to need to use. So here, I'm told the total mass of the sculpture is 736 grams. And that's very useful to know. We can then work out, I suppose, what the total volume will be. And if I work out the total volume, then I can work with that. I'm told that the cuboid part is iron, so this bit is of iron. That's the density. I think I probably could work out the volume of that. So let's work out the volume of my cuboid. So the volume of my cuboid is going to be 8 by 3 by 3 because it's going to be square based. So 8 times 3 times 3, and that is 72 square centimeters. So first thing I do, 72, well, cubic centimeters, beg pardon, not square centimeters. And then I know that the density of that is 7.2. So the density is 7.8 even, 7.8 grams per cubic centimeter. So I can work out the mass. Mass will be density times volume. So the mass of the cuboid is going to be, that's 72 times 7.8. Put that into my calculator. 72 times 7.8, and that's going to give me 561.6 grams. First point that I'm going to be able to work out. So then I'm told that the total mass of the sculpture is 736 grams. So I can work out the mass, therefore, of the pyramid. So I can say that the mass of the pyramid must be that 738 take away 561.6. So I put it into my calculator. 738 take away 561.6, and that tells me that the mass of my pyramid will be 176.4 grams. Well, I can work out the volume of this, so I can say the volume of my pyramid is going to be the base, so that's 3 times 3, because it's a square base, times the height, which I worked out to be 7, divided by 3. So I reckon that's going to be 21 cubic centimeters, even without using my calculator, because we can take away 3 from both sides. So 1/3 of the base times the height, and that gives me 21 cubic centimeters. Well, I can work out now, what's the density going to be of copper? Well, density is mass over volume. So therefore I can say that the density of my pyramid or my copper is going to be the mass 176.4 divided by 21. So put it into my calculator and I get an answer of 8.4. Oops. And that's going to be 8.4 grams per cubic centimeter. So yes, that's a little bit complicated. There's some stuff there that we didn't know how to do, but the actual calculations are calculations that you are familiar with. Let's put it into MathsWatch. So there you can see I've typed out my working out and hit submit answer. And we would be, in theory, able to get a grade 6. So I skipped question 7. And it did give you the formula there for the volume of a pyramid, even if you weren't familiar with it. It's a case of what do I know? Even if I can't get all 5 marks for that, can I get 2 or even 3 marks? Each of those contributes significantly. Okay, we have a question now looking at scale factor. And this is an enlargement question. So first thing I'm going to do is I'm going to mark where my center of enlargement is, 2, 6. So that's going to be just there. I'm going to draw some ray lines to help me with this calculation. So let's draw some ray lines. We'll have one there, and we're going to have one going through each of these points. So there's one there. Let's have another ray line to help me out with my calculation here. And one goes there in that center of enlargement, 2, 6. And the other one goes through the other vertex. So it looks nice. And then one more. I find ray lines are really helpful to work out our enlargements. And then this is going to go through that point there. So I'm told it is a scale factor of 1/3. So that means if I'm going starting here and going to there, I'm going to go 1/3 of the way along here. So let's just count that. That's 1, 2, 3, 4, 5, 6 along and 3 up. So I can say that if this is 6 along and 3 up, well, 1/3 of the way, 6 along, is 2 along and 1 up. One of the reasons for drawing my ray line is that it allows me to check that actually my calculation is on the ray line. Let's do another one. If I go look at this point here, that's 1, 2, 3 down and 3 to the right. So 1/3 of 3 to the right and 3 down is 1 to the right and 1 down, which again is on my ray line. Very good. And then finally, I have 1/3 point. So if I go along here, from here to there, that's 1, 2, 3, 4, 5, 6 along and 3 down. So 1/3 of 6 along and 3 down is 2 along and 1 down. And again, that's also on my ray line. So then the last thing that I have to do is to draw out this diagram. So I'm going to grab my ruler and I'm going to draw a triangle as accurately as I can using my tools. Now obviously this is a lot easier actually on pen and paper. Oops, that didn't work. Try it again. So there is the first bit. I'm now going to spin that around. I'm going to have a nice vertical line going from there to there. And oops, again, struggling with my points there. And then the last bit of my line, that'd be worth just dropping some of those points, get rid of them so that I can see more easily where I am. And then I want to draw this last bit from there up to there. So I'm going to just draw that one. Oops, that didn't work. Try that again. And we're going there. So let's just have a look at that. And we'll get rid of that point as well so we're not getting distracted. So get rid of some of those lines just so that I can see it nicely. Oh, I think I actually did that wrong, didn't I? Because I just accidentally removed those. I'll just redraw them. So there I have redrawn it and we can hit. Now the second part has to do what we call area scale factor and volume scale factor. We haven't looked at it. I'm not going to worry about it. I'm not going to do it just for now. But let's get some marks if we can for our triangle. and we got a number of marks there. And moving on to question 10. So many questions we got here. 18. Histograms, again, we haven't looked at this. We haven't done frequency density. I'm going to skip this question. And the reason I'm skipping it is there are some questions towards the end where I think we can pick up some marks. So let's have a look at question 11. And here we are looking at what we call bounds and intervals. And again, I am going to skip this one because it has to do with, for example, we're looking at the fact that if I have 330 milliliter cups, the nearest 10 milliliter, I'm recognizing that the smallest capacity could be 325 milliliters, or the largest capacity could be 335 milliliters because it's rounded to the nearest 10. And this is a bounds question, and again we'll do that later on in years 9, 10 and 11. Looking at question 12, we have a thing here on inversely proportional. Well, actually you probably could have a go at this question. I'm going to show you the answers, but again I'm not going to do it. So instead of as the one increases, the other one decreases, well, your answers are there, but again, I'm not going to look at them just now. Question 13. This is very much a year 11 question. It's what we call circle theorems, and it's quite challenging, but it's a lot of fun because geometry does open up all sorts of possibilities for us. Question 14. We can do. So even though it's further along towards the end of the paper, this is a doable question. So first of all, I start off with function A. If I start with -7 and add 5, that gives me -2. If I double that, I get -4. So that's the sort of question we did this when we were looking at some stuff on functions and finding inverse functions. So then over here, here's another one. We want to find the inverse function. Well, I'm going to show you this one so we can have a play with that. So here I want to sketch this going the other way around. So there is my opposite. So I'm starting with basically x and going here. Oops, it wasn't very good while drawing. And this is going to be the inverse of x, if you like, or the function -1 of x. So there's your concept. So what do I have? That's going to be -1 because it's the opposite of that. That's going to be times 3. So if I start with x, this becomes -x. If I start multiply by 3, I end up with -3x. So I could say that my inverse function of x is going to be, I beg your pardon, it's on the wrong, haven't I? That was completely wrong. Let me just start that again. I made a mistake because it happens and I've done it wrong. Start with x, take away 1, I get x -1. That was badly said, Mr. Kane. And then over here, I'm multiplying by 3, so I get 3 times x -1. So I can say correctly that the inverse function is 3 times x -1. So my apologies for that. So we'll again put that into MathsWatch. Now the third part is something we haven't done. It's quite complex. I'm not going to worry about that just for now. And now I notice, of course, actually I've missed part of the question, haven't I? Because I've got this bit here I haven't done. So I can do some similarly in backwards. If I started with end with 13, what's going to be here? What's going to be back there before the times 2 would be 6.5. And what plus 5 gives me 6.5? Well, I reckon that's going to be 1.5. Let's just check that. 1.5 plus 5 is 6.5 times 2 gives me 13. What if I started with n? Well, if I added 5, I would have n plus 5, just like that. And if I multiplied by 2, I would have all of that times 2. Whoops. Now, again, I think that all of this is stuff that we should be able to have a go at. We've seen it in class. Okay, part C isn't. And that would, again, be taking us right up towards a grade 6. What about question 17? Sine and cosine, haven't done it. Don't worry about it. Doesn't matter. Question 16. Well, we've got a little bit of simplification. Part B, we can't do. Okay? But part A, we can do. 5y to the 4 divided by y to the minus 2. So we learned all manner of really, really useful laws to do with working with indices. So for example, if you remember, we learned that if I had, let's say, x squared, and I multiplied it by x3, then my answer was x to the 2 plus 3. And we could write that in terms of x to the a times x to the b is x to the a plus b. And we saw that if I had, let's say, x to the 4 divided by, let's say, x to the 3, then that would be x to the 4 minus 3, which would be x to the power 1. If you weren't sure about that, we could say, well, that's just the same as x times x times x times x divided by x times x times x. We can cancel those out. We can divide top and bottom by x, and you end up with x to the power 1. Well, this is the same thing here. So we have 5 times y to the 4 divided by y to the minus 2. So we write that as 5 times y to the 4. Now, because we're dividing, we're going to subtract. We're going to subtract there. So 4 minus negative 2. And that is 5 times y to the positive 6. 4 take away negative 2. Well, we've got a calculator. We can do it in our calculators. So actually that one, even though it looks hard, you can pick up some marks just for getting that question. And there you go. And I'll just submit that and we get another mark. Worth picking up every single mark. Okay, I've got some wrong. I haven't done this one. It's not a problem. I've still got the mark for this one. Question 17. Okay, the cube root of 81 over 3. Now, that does seem a little bit complicated, but we have a calculator. So we can have a look at that. We can see what we could come up with. So I'm going to show you what we do. And the thing with a question like this is we write everything as a power of 3. Because I know that 81 is 9 times 9. And I know that 9 is 3 squared times 3 squared. So 81 is 3 to the power 4. So I can write that as 3 to the power 4 divided by 3 to the power 1. And this is a cube root. Well, a cube root is the same as to the power 1/3. Because a square root is to the power of a half. Because if you multiply a square root by itself, you get a half plus a half gives you the whole. So this ends up as 3 to the power 4 over 3 divided by 3 to the power 1. And that is going to be 3 to the power 4 over 3. We take away the powers and I get 3 to the power 1/3. Now, that's probably a little bit challenging, but actually it's only a step further from some of the work we did back before Christmas. And this is the sort of thing where you can pick up those interesting marks. And this is rather hard to write in terms of MathsWatch. It looks really complicated. That's why I did it by hand. But that would still give me those 3 marks. And then the last question, we have something here about crates. Actually, this is a Pythagoras question. And I think actually it's well worth taking a look at it because we looked at Pythagoras just in the last couple of weeks. So we have a crate open to top, shape of a cuboid. Those are dimensions 46 by 46 by 70. He has a stick of length 90. He places the stick so it extends above, calculate the length of the stick that extends out of the crate. Now, B, it's a bit harder, but A, we can do. We just need to model this. Okay, here we go. So I have a stick here. It's going to go diagonally from one corner to the other. And I want to work out the length from A to B. And how do I do that? Well, I'm going to use my knowledge of Pythagoras because I want to work out this diagonal here. Because I know that when I do this B to C to A, that will be a right angle triangle because that's horizontal, that's vertical. So I want to work out B to C to A. Not drawn very well, but never mind. Or that should be D, shouldn't it? Beg your pardon. D to C to A. That's what I want to work out because that's going to be a right angle triangle. And I can use Pythagoras. I know that this will be 70. Okay. So how do I find A to C? Well, again, I can use Pythagoras again because here is my rather wonky drawing triangle. That's 46 and that is 46 because that's C to B to A. So what can I do? I can say that AC squared is going to be 46 squared plus 46 squared because that's my Pythagoras. Put in my calculator, 46 squared times 2. That's 4232. And actually I'm going to just write for now that AC is the square root of 4232. I'm not going to bother about putting in the decimals. We don't want to make any mistakes. So that's my AC. That's root 4232. Now I can put that over here now. That's going to be root 4232. So I want to work out what is AD. What's the length of that from A to D? Well, I can again use Pythagoras. I can say that AD squared is going to be the square root of 4232 squared. You see why I left it as a third? Plus 70 squared. So if I put it in my calculator, I can do 4232 plus 70 squared, and that is equal to 9132. So what is AD going to be? What's the length from the corner to the corner? Well, the square root of that works out at 95.56 centimeters. So that tells me that the length from A to D is 95.56 centimeters. But my stick is 99. So how much does it stick out? Well, the remainder is going to be 99. Take away 95.56 and put that into our calculators. And I'm asked to give that to, doesn't say what dimension, what rounding. Well, that works out at 3.438 centimeters. I'll probably just write that as 3.4 centimeters. So yes, that is complicated, but actually we did do some stuff like that in our recent section on Pythagoras. So there, I've typed that in, hit my submit answer. Wow, up to grade 7, just from what we already know. I've skipped a few questions, of course. And then part B, I'm just going to show you quickly. I've only got 2 minutes left. Might not have time to do this in terms of actual timing, but how do we do this one? Again, we're doing SOHCAHTOA. And here you can see I've drawn the triangle again. That's the one that was here. And basically I want this angle here. That's the angle made with the base. And so I'm going to say that's my opposite. That's my hypotenuse. That's my adjacent. I'm going to use my tan. And I'm going to say that the tan of that angle, oops, of A, is the opposite 70 over that root 4232. And if I put that into my calculation, I get that angle, A, we'll call it that just for now, works out, if I do inverse tan of 70 over 4232, that gives me 47.1 degrees. Do I have time to fill it in, or have I missed the deadline? Oh, and I just missed the deadline. So there, I've just reset the exam. Now you'll see I've got 0 marks because we just started again. I wanted just to see that this question does work, and you can see there we've got the correct answers. So there you go. We went through many of those 18 questions. We ended up with a grade 7 by the end of it. Now, you obviously don't know have everything, but by the time you're in year 11, I would hope that you would be in a position to be aiming for grades 8 and aiming for grade 9 in those questions. So if you were getting a grade 3 in our assessment, I hope that you are now in a position where actually you can see this is how it got to 4 or maybe even a 5. If you were in a grade 4, I hope that you were saying, actually, yeah, I could have tried that question and that question and that question, and I will do better next time, because it's all to do with exam practice. So what I'd like to ask you to do in conclusion is go back to my Satchel 1 entry and just leave me a comment. Tell me one thing that was really helpful from watching this walkthrough. And that's one way of me just ascertaining that actually you have watched it, and then it's useful for me to receive feedback as well. So thank you very much for watching it, and I wish you well in your next higher paper.